Okay, so check this out. We are once again taking a graph and trying to come up with the equation, which we've done for many different types of functions over the last little while. We're doing the same thing again here. The only difference is we are now doing them when there are p.o.d.s involved. Okay, when there are points of discontinuity. So this first one isn't a rational function, it's just a linear function. So this is an easy one to start off with. Okay, linear functions, you can start by getting the y-intercept and the slope. So you can see that the y-intercept is a positive 1. So we just write the equation like the equation of a line where we have y is equal to mx plus b. We have a slope of positive 1. We also have, a y-intercept of positive 1. We also have a slope of positive 1. First of all, this is sloped in a positive direction. We go up and to the right to get to the next point. And you can see here, if you take any 2 points on the graph, you go up 1 and over 1. So 1 over 1, of course, is a 1. Don't even need that 1 there. You can just leave it as an x. So we have the basic equation is x plus 1. Y is equal to x plus 1. However, there is a p.o.d. that we have to consider. Okay, we have a p.o.d. of 3, 4. So the x value of the p.o.d. is at positive 3. And remember that the p.o.d.s are the ones that cancel. So what we have to do here is we have to put an x minus 3 on top and bottom, because those are the ones that would cancel and give us a p.o.d. But since we're working backwards, we're working to build up the equation rather than cancel things. So we're putting in the x minus 3's on top and bottom that would normally be canceled and would be considered to be a p.o.d. at x equals positive 3. No VAs, so there's nothing else on the denominator, and you can leave your answer like this. This is the correct answer right here. Or you can multiply out the top so that you'd get x squared minus 2x minus 3 outside of x minus 3. And then this is the function right here in multiplied out form. Okay, so that one's not too bad, all right? That one's a linear function. When you get into the rational functions, they get a little bit harder, but we already finished getting the equation of a rational function, so we just have this extra p.o.d. business to handle. So first of all, okay, if we are getting the equation of this, let's just do it the same way that we were doing it before without the p.o.d. You were getting a mapping notation, so you can see that the graph has shifted 1 unit to the left, or you could look at the vertical asymptote for that. You could see that there is no translation up or down because the horizontal asymptote is still along y equals 0, the x-axis. So nothing to go after the y. There is a reflection. I'll put a negative in front of y because originally the curves go in the upper right and lower left corners. So you can see that how that graph has been flipped over the x-axis, and now it's in the upper left, lower right. And there's also a vertical stretch of 2, which comes from taking our intersection of our asymptotes and going over 1 up 2 or over 1 down 2 to get to those. So we would come up with the equation would be 2 over x plus 1 and no number at the end because there's no vertical translation. That is the equation of the function without the p.o.d. But because there's a p.o.d. at x is equal to positive 3, okay, because that exists, all right, we have to put in our x minus 3 factors on top and bottom because those are the ones that cancel the p.o.d.s. The VA of negative 1 we already have as the denominator of x plus 1. And now we can just multiply out, and we would have 2x minus 6. Oh, sorry, this is a minus 2. So this will be a minus 2x plus 6. And then we have x squared minus 2x minus 3. And there we have the equation of this function right here, which you can check your answer using Desmos. You'll get the exact same graph right here. Okay, so we're going to move on to example 3 next, which is even harder. The reason why this one is harder is because there is a vertical translation as well. The horizontal asymptote is no longer the x-axis, it's been moved up. So once again, what we do is we get the equation of the graph without the p.o.d. first. and it's a rational function, so you may want to use a mapping notation first. So doing what we've done in previous exercises, we can say that this graph moves 2 units to the left. The vertical asymptote is now at -2. It is moved up 3 units, so we have y plus 3. There is no reflection because it's still in the upper right and lower left corners. But if we take a look at the intersection of the asymptotes, we go over 1 and up 2. So we have a vertical stretch of 2. So therefore, our equation would look like this. We'd have 2 over x plus 2 plus 3. And now we have to put in our p.o.d number, which is also at x is equal to positive 2. Normally wouldn't be a problem, but the problem is that we don't no longer just have a fraction. We've got this plus 3 in the middle as well. So we have to do some things to this one. So let's take a look at what extra algebra we have to do here. The very first thing is, before I put in my p.o.d number, which once again we said was at x is equal to positive 2, we said there's a p.o.d, but before we put that onto the top and bottom of the fraction, we have to deal with this plus 3 here. Okay, we have to get common denominators is what's happening here, all right? So we got to take this transformational form, and we have to put both parts together so that it's just a fraction. So we have to get common denominators. So what I'm going to do right here is my 2 over x plus 2 is good, but on the 3, I'm going to multiply the top and the bottom by x plus 2 to get common denominators. So this works out to be 2 plus 3x plus 6, that's distributing through the brackets, all over x plus 2. And if I simplify that down, I get 3x plus 8 over x plus 2. Now that's not the final answer. That's really just a rational equation right here, no longer in transformational form. Okay, I got common denominators and I put them all together. Now I have to deal with the p.o.d. There's a p.o.d at x is equal to positive 2, and I forget the y coordinate. I could go back and look, but it doesn't make a difference to my calculations. I have to put my p.o.d value on here, so the corresponding factor for positive 2 would be x minus 2. So now I've got to multiply all this out, and if you do this, okay, you're going to wind up with 3x squared plus 2x minus 16 over x squared minus 4. Again, you may need some extra steps to distribute everything out and collect like terms, but you should wind up with this, and if you check Desmos, you should get the correct answer for that as well.